Welcome back to your favorite Algebra 2 course, Intermediate Algebra. Today we're going to talk about the remainder and factor theorems, which is going to involve a lot of polynomial long division and synthetic division. So we're going to use long division, synthetic division to introduce those, to talk about the remainder theorem and factor theorems. Okay, so the remainder and factor theorems. Okay. Now, before we do some polynomial long division here, let's go back and talk about, um, let's say you were some old school long division they used to do in grade school. Let's say you're doing 131 divided by, let's say we got 4, right? And you say, okay, well, let's see. That's just, or that, which is, of course, is the same thing if you see it written like that, right? And you put this 131 right there, and your 4 right there, right? Your 131 there is your dividend, and your divisor there is your 4. Whatever you get for your answer is your quotient up there. When you're thinking about this thing, and sometimes people forget, well, where do I put, who do I put where? I know it's kind of simple, and you've done this a lot of times, but some people do forget that. So if you forget, you say, hey, whoever's, this is Vegas style remembering method, whoever's at the top of the list gets in the nightclub, right? Whoever's at the bottom of the list is outside the nightclub. So that's one way you can remember who goes where if you do forget that. Okay. So 131 divided by 4. And then you do this, you say, well, 4 goes into that 13 how many times? 3 times, right? You're trying to match that 13. 3 times 4, 12. Then you subtract that 12, you get 1. You bring down that 1, you get 11. 4 goes into 11. Looks like twice. 2 times 4, 8. And then you got to remember, you got to subtract the 8, and you get 3, right? And that's your remainder. And then you would write the answer 32 and 3/4, right? 32 and 3/4, but we always wrote it 32 and 3/4. Okay? 32 and 3/4. So that's a nice little reminder of how you would do it with numbers, right? So now if we're going to do, extend this page a little bit, let's talk about it with some polynomial long division now, okay? So let's say we're going to divide, oops, D-I-V-I-D-E, divide, let's see what I got here, 4x to the 4th minus x squared minus 18x plus 8, and I'm going to divide that by x squared plus 2x plus 3, x squared plus 2x plus 3. Of course, can also be written as 4x to the 4th minus x squared minus 18x plus 8 divided by x squared plus 2x plus 3, right? So when you're doing this, again, whoever is on the top is your dividend. So our dividend here is that 4x to the 4th, and you want to write this, degree by degree. So you notice how there's no something x cubed. You want to leave a space there. It just makes the long division easier when you do this. You subtract that x squared, you get minus 18x, you get plus 8, right? You're dividing this whole thing by x squared plus 2x plus 3. Notice that went down in degree perfectly. 2, degree 1, 2 to the x, right? Or 2x, and then degree 0, which is your constant 3. Okay, you want to make sure that that one also goes down in degree perfectly. Okay, so another way to think about that is if you're dividing f of x divided by d of x, right, then this becomes your f of x goes in here. That's our dividend, right? Our d of x is our divisor here. our divisor. And then we get our answer. We're going to call that q of x. Q of x, that's our quotient. Quotient. And then down here at the bottom, we're going to get our r of x. That's our remainder. Our remainder. Okay, that's our remainder right there. So f of x over d of x ends up being q of x, our quotient, plus, then we get our remainder, and we got to put that remainder over our divisor, just like we did in that above problem. Okay, so f of x over d of x equals q of x plus r of x over d of x. Sometimes you'll see people write that same thing as, let me extend this a little bit. They'll write f of x over d of x equals q of x plus r of x over d of x. And we're going to talk about this a little more later. But sometimes you'll see people write it this way. If I was to multiply all of this by d of x and this whole side by d of x, right? So I have to distribute that. And that ends up being f of x equals q of x, d of x, plus r of x. In other words, my dividend is equivalent to my quotient times my divisor plus my remainder. Okay, that's a really, really important concept in algebra. Okay. All right. So, anyways, that's a little bit the little abstractness to this, but let's go ahead and see. Let's see our step processes here for actually doing the problem. Okay. So I'm looking at this 4x to the fourth, right? I'm looking at that term and I'm trying to match it. Trying to match that. So I say what times x squared gives me 4x to the fourth? What times x squared gives me 4x to the fourth? I say, oh, it's got to be 2x squared, right? Now, so I say it's 2x squared. Now I actually put that right above the same degree. So I say, oh yeah, 2x squared times x squared. I'm sorry, good grief. That's not true. 4x squared. Hee hee. I say, yeah, 4x squared. Now I multiply it through. 4x squared times x squared is 4x to the fourth. We matched it, right? Well, I got to keep multiplying it through the entire divisor. So now I go 4x squared times the 2x. That gives us 8x cubed, right? And then 4x squared times 3, 12x squared. Now remember, do you remember how we now subtracted this? We actually subtract the entire thing. In other words, we got to change each of these signs. Change, change, change. So that 4x to the fourth minus 4x to the fourth, see how that cancels? That's why we wanted to match that. And then it goes 0x cubed minus 8x cubed is a minus 8x cubed, right? Negative 1x squared minus 12x squared, that's a negative 13x squared. And we go ahead and bring down the next term, minus 18x, okay? Now we're trying to match this one, okay? So I say what times this x squared right here, times that x squared, what times x squared gives me negative 8x cubed? What times x squared gives me negative 8x cubed? And I say, oh, negative 8x does, right? So I replace my question mark here. I say negative 8x times negative 8x times positive x squared gives me negative 8x cubed. And then I do it through to each of those. So negative 8x times, you see the 2x right there, negative 8x times 2x is a minus 16x squared. And then negative 8x times that positive 3 right there, negative 24x, okay? Don't forget, change your signs. Change, change, change. So those, in those cases, those all become positive. Negative 8x cubed plus 8x cubed, notice that cancels. That should cancel each time. Negative 13x squared plus 16x squared is a 3x squared. Negative 18x plus 24x is a positive 6x. And finally, bring down our last term, that plus 8, okay? Now I'm looking at 3x squared, so I got to match that 3x squared. So I say what times x squared gives me 3x squared. I say, oh, that's just a 3. because 3 times x squared gives me 3x squared. So I put a plus 3 right here. 3 times x squared, 3x squared. 3 times 2x, 6x. 3 times 3, 9. Don't forget, change your signs. Change, change, change. Gone, right? 6x minus 6x. Hey, that's gone. 8 minus 9, negative 1. There's my remainder right there. I'm done, right? That's my remainder. So the question becomes, how do I write this, okay? Notice over here again, f of x over d of x. So that is our, um, f of x is our dividend, you know, d of x, of x is our divisor, is our quotient. So we write our quotient, and then we write the remainder over our divisor, okay? Very similar to how we did that, or, you know, just like the numbers there. So our answer becomes 4x squared minus 8x plus 3 plus remainder over divisor, x squared plus 2x plus 3. That is our answer, okay? That's how you do polynomial long division. Now let's do another one here. How about, let's divide these two. Let's take, hold on here. All right, let's divide that. Also written x cubed minus 3x squared plus x minus 8 over x minus 1, right? The person at the top of the list gets in the nightclub, x cubed minus 3x squared. I got to make sure these go down in term, or in degrees perfectly. Notice it goes degree 3, x cubed minus 3x squared, right? The next one should be something x. I have that, so I don't have to put in any placeholders. Remember how we had to put in, like, what was the last one? We had to put in over here. Remember how we had to put in 0x cubed because there was nothing x cubed there, so we had to put in that placeholder, if you will, to make it easier. Well, this one we don't, right? It goes down perfectly. This one, x minus 1, goes down perfectly as well. Okay? So then we say, all right, what times x gives us x cubed? What times x gives us x cubed? And of course, that would be x squared. And I put it right over the other x squared, right, over that same degree in the dividend there. So x squared times x cubed, right? Remember, I'm multiplying this thing by that. And then I multiply that by that as well. X squared times the negative 1 x squared, right? Don't forget, change your stinking signs, right? Gone. X cubed minus x cubed, gone. Negative 3x squared plus a 1x squared is a negative 2x squared. Go ahead and bring down that plus x there, and you're going to do the next one. Okay, so we got what times x gives us, I'm trying to match this right here, gives you negative 2x squared. What times x gives you negative 2x squared? And you say, well, that's a negative 2x. Negative 2x does, so that's what I'm going to put. I'm going to put in a negative 2x, and I'm going to multiply by each one of those in the divisor. So negative 2x times x, negative 2x squared. We matched it, right? Negative 2x times a negative 1, positive 2x. Don't forget, change, right? So now you have a x minus 2x is negative 1x. Bring down that minus 8, and you're matching the negative x. So you say, what times x gives you a negative x? Oh, well, that's got to be negative 1, right? It's going to be a negative 1 here, minus 1. So then you multiply through negative 1 times x, negative x. Negative 1 times that negative 1, plus 1. Don't forget, change. Negative 8 minus 1, negative 9. There's our remainder. So our answer to this becomes x squared minus 2x minus 1 plus the remainder over that divisor, x minus 1. Okay, so that's another good example there of polynomial long division.